All right, so let's go to the review sheet here. So if you take a look at number one wants us to solve this system of equations, and it says which number is not the value of any variable in the solution to the system. I'm going to underline the word not so we really see that. Okay, now, with multiple choice, I don't actually want you to go through and solve it by hand, okay? We're going to save that for the part twos. With multiple choice, we're going to do this in our calculator. All right, so let me show you how to do this. Okay, so what we're going to do is we're going to go through. We're going to first create a matrix. So in your calculator, let's see if I can do this. You're going to go to second. Let's see what it says matrix right there. We're going to hit that. And we're going to go over to edit and hit enter. Now, your calculator may already say 3 by 4. Mine says 1 by 1. But if you notice here, we have 3 rows, 1, 2, 3, and we have 4 columns. A column for the x's, a column for the y's, a column for the z's, and a column for the numbers on the right-hand side of our equation. So we want to create a 3, and then I'm going to hit enter, by 4, and I'm going to hit enter, matrix. And we're just going to plug in the numbers. If you remember from class, if we go through the first row here, we have a 1 in front of the x, a 1 in front of the y, a negative 1 in front of the z, and a 6 on the right-hand side of the equation. So in our matrix, for the first row, we're going to plug in 1, 1, negative 1, 6. All right, so let's do that. So 1, 1, negative 1, and 6. I like to hit enter after the number. You could hit over as well if you want. All right, so then now let's look at the next row. It goes 2, negative 3, 2, negative 19. So 2, enter, negative 3, enter, 2, enter, negative 19, enter. And then finally the last row, if you follow the trend, goes negative 1, 4, negative 1, and 17. Okay, so what we've done is we created our matrix. Now, I want to clear out of here. So see right here where it says quit, I'm going to hit second mode. And then I'm going to go back into matrix. So I'm going to go back to second, and this little button right here that says matrix on top. And now I'm going to go over to math. And this becomes easier. The more you do it, the more you remember, you know, what to hit to get to this. Go over to math. And you want to scroll down till you see RREF. I like to scroll up. I think it's faster. And we could see right here it says RREF, okay? Reduce row echelon form. I'm going to hit enter on that. Don't pick REF, pick RREF. And then I have to tell my calculator which matrix I'm using. So I'm going to go back to matrix for the 3rd time. So again, here's my buttons. I'm going to hit second matrix. And I'm going to choose the first one, right? That's where we entered in our value. So I'm just going to hit enter, or you could hit the number 1. And now I'm saying, you know, let's see it. Let's see the answers here. So when I hit enter, I can see it. Let me just explain what this means. So, all right, this means, see how the 1 is in the first spot, just like the x up here is in the first spot? So it's saying that x is equal to negative 1, y, since that's in the second spot, is equal to 3, and z, since that's in the third spot, is equal to negative 4. Okay, so again, it says 1, 3, negative 4. So x is negative 1, y is 3, and z is negative 4. So we want to know which value is not in the system of equations. Okay, so we have negative 1, we have 3, and we have negative 4. So it looks like choice 2. 2 is the answer. That is not a value in our system of equations. Okay, so number 2, it says the graphs of these two equations are drawn on the same set of axes, and they want to know which one of these is a solution. Like, we may have more than one solution when we do it graphically, but we want to know which one is not a solution. All right, so, I mean, this is multiple choice. I'm going to do this on my calculator. I'm going to go to y1 and graph this equation, and then I need to get y by itself in the second equation, so we could easily do that by subtracting 3 from both sides of the equation, right? So that'll leave me with y equals, those cancel off, x minus 3. Okay, so what I'm going to do is I'm going to plug, again, this into y1, this into y2, and I'm going to graph it. Okay, so I went to y1 and plugged in this first function, and I went to y2 and plugged in the second function. Now, you can do one of two things. You know what, let me just move this over so we can see our answer choices. All right, you can either hit graph, right? So here's graph. And you can look at the graph, and you can see, actually it's kind of hard to see exactly where it's intersecting in there. So I guess instead of looking at my graph, and you know, that could be hitting it in 2 spots. I could always zoom in if I want. Let me do that. Let me hit zoom. Okay, here's zoom. And trace 2 says in. And I'm just gonna move my cursor. Okay, I'm gonna use my arrow keys. And I'm gonna move my cursor until I get in that area and hit enter. It'll zoom in. And let's see. Yeah, look at that. We do. We have 2 points of intersection. There's one here and one here. Now, it's kind of hard to tell exactly where they are. So, I mean, your best bet is, well, you could do one of 2 things. You can always go to second, trace, intersect. Okay, so let's do that. I'm going to hit the second, trace, and then trace 5 is intersect. I like to hit the number 5. It kind of is like wasting time to scroll down to it and hit enter. And then I'm going to move my cursor. Let me start with this one. I'll move my cursor just as close to, you know, this first point of intersection as possible, and then I hit enter 3 times. Now, I just want to point out, if you're, let me hit enter, 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 and there's my first point of intersection at -2, -5, which if I look at the answer traces, I don't see that. So it looks like they're going to be using this other point of intersection. Now, I just want to point out, if you're using the app on the phone, the calculator app, you do it a totally different way. So I recommend using the one on the Chromebook instead for this. All right, so again, it looks like we're using this point of intersection. So let's go back to second, trace, and trace 5. Okay, again, it's much faster just to hit the 5 than to scroll down to it and hit enter. And now I'm going to use my arrow keys, and I'm going to move my cursor over towards that other point of intersection. It doesn't have to be right on it, but as close, you know, to it as possible. And now I'm going to hit enter, enter, enter. And here we could see it's at -1, -4, which look, that is choice 2. So choice 2 is our answer. Now, one thing that I do want to say, let me just circle choice 2. Sorry, I'm just opening the pen here. There we go. One thing I do want to say, though, you know, because we could tell that we were at whole number points of intersection like this, you could just go to your table of values, right? So you can go to second, graph, and if we look at our table of values, let me get a little closer, what you'll notice is that aren't the y values the same here at -5? So -2, -5 is a point of intersection. And then also, aren't they the same here at -4? So -1, -4 is another point of intersection. Sorry about all this shaking. I'm making you guys seasick watching this. It's hard to hold my heavy iPad with one hand and use the calculator with the other. But either way, we could see that our 2 points of intersection are -2, -5, and -1, -4. Okay, and one other thing I want to point out, if you prefer to do this algebraically, you don't have to use the calculator, okay? You can solve this algebraically. You could take this x squared plus 4x minus 1 and substitute it in for the y and solve it algebraically. I'll do that as well. And if you don't like to do it that way, you know, you could just fast forward. Okay, so if you'd like to do it algebraically, since y is equal to x squared plus 4x minus 1, right? Since this is what y is equal to right here, we can take this and substitute it in for y into the other equation. So instead of having y plus 3 equals x, we'll have this plus 3 equals x. Okay, so I just replaced the y with what y is equal to, and I brought down the plus 3 and the equals x. All right, so let's solve this. So since we have a square in our equation, we want to get one side of the equation equal to 0. So I'll do that by subtracting x from both sides of the equation. And then on the right-hand side of the equation, those cancel, and I am left with 0. So I'll take this x squared and bring it down. And then 4x minus x would just be positive 3x. And -1 plus 3 is positive 2. I actually prefer to solve it algebraically over graphically. All right, so then we're just going to factor. So we're coming up with 2 numbers that multiply to 2 and that add to 3, which would be positive 2 and positive 1. Oop. Let me rewrite that. That was pretty messy, right? Okay, so x plus 1. And then when I make a t-chart, I get x equals -2 and x equals -1. Now I have to find the y values that correspond with these. So you know what I'm going to do, just because I'm kind of running out of room here, I'm going to rewrite these. So we have x equals -2. There's the left side of our t-chart, and x equals -1. All right, so now let's find the y values that correspond with them. So, I mean, you can use either this equation here, or if you wanted to get y by itself in this equation, right? Wouldn't you just, we did this earlier, wouldn't you just subtract 3? And that would leave you with y equals x minus 3. Okay, here I'll do it in a different, just in case you can't visualize that, I'll do it in a different color. And what would happen is, those would cancel, leaving you with y equals, and then we have x minus 3. So I'm going to use this equation, write that over here, and I'm going to use this equation to help me find the y values that correspond with the x values we found. All right, so let's first start off by plugging in a -2. So I'm going to replace this x with a -2. Okay, and that's equal to -5. So what we could see here is that when x equals -2, y equals -5. So that's 1 point of intersection, -2, -5. Remember, you always write the x coordinate first, so there's one solution. Okay, now let's go over here, and this time we're going to replace the x with -1. So we'll have -1 minus 3. And since -1 minus 3 is -4, the other point of intersection would be -1, -4. And again, the answer only put one of these points of intersection here, and the one they put was -1, -4. All right, now number 3 says, using the substitution method, Ken solves the following system of equations algebraically. All right, which equivalent equations could Ken use? Or which equivalent equation could Ken use? All right, well, if we're going to solve this using substitution, basically algebraically, we need to get either the x or the y by itself in one of these two equations. Now, I'm looking. This x has a 2 in front of it. This x has a 3 in front of it. This y down here has a 2 in front of it. Even though this has a -1, it's still a 1 in front of the y, even though it's a -1, right? This is going to be the easiest variable, in my opinion, to get by itself. So I'm going to start with this equation. This may not have been what Ken did, but it seems the most logical to me. So I'm going to take the 2x minus y equals 5, and I'm going to get the y all by itself in that equation. Now, to be honest with you, I think the easiest way to get the y by itself, let me just bring down this equal sign, is to take this y, since it's negative, and just move it to the right-hand side of the equation. Because when you take a -y and move it to the other side of the equal sign, doesn't it become a positive y? Okay? And then what's going to happen is, well, I wanted to get y by itself. So since I moved the y, the -y over here, and it became a positive y, I'm going to need to take this 5 and move it to the other side of the equation, which makes it a -5. Okay, and I could bring this 2x down. So what we have here is y is equal to 2x minus 5. All right, so this is what y is equal to. Now, since y is equal to 2x minus 5, can't we replace that for y into this other equation here? So instead of 3x plus 2y equals -3, we'll have 3x plus 2 times what y is equal to, being equal to -3. All right, so let's write that out. So I'm first going to write 3x, and then plus 2 times, in place of this y, we're going to put what y is equal to. So 2x minus 5. And then I'm going to take this equals -3 and bring that down. All right, let's see if one of those is in the answer choice. If one of the answer choices says that. Yes, look, right here, choice 3, okay? This says the same thing as choice 3. So they didn't actually want us to solve it. They just wanted to know kind of what was like one of the beginning steps of what Ken could have done. Which equation is equivalent to what Ken would have if he, used the substitution method. And here it is. All right, so if we take a look at number 4, to the nearest hundredth, the value of x that satisfies this equation is what? All right, well, we haven't actually learned how to solve anything like this algebraically, so we're going to do it graphically. Okay, so, we've already learned if we want to find out when one side of the equation equals the other side of the equation, we could substitute the left-hand side of the equation right here into y1 into our calculator, and we can substitute the right-hand side of the equation into y2. And if we want to figure out when they're equal to each other, you just find their point of intersection. Okay, so I plugged in the left-hand side of the equation into y1 and the right-hand side of the equation into y2, and then I'm going to hit, you could hit graph first and look at it. Oh, look, my graph is still, it's on a funky window from the last question, so I could just hit zoom, and then choice 6, the standard window. Okay, that'll give me your normal -10 to +10 window on the x and y axis. All right, so we could see the point of intersection is somewhere over here. Now, I'm going to actually go to second. Oop, I hit second, and then trace, right? You always go to second trace when you want to calculate something about a graph. I'm going to choose choice 5, intersect. I mean, and I can see there's really only one point of intersection here, so I really don't have to move my cursor. If I want to move it closer to that point of intersection, you know, I can, but now I'm going to hit enter 3 times. So enter, enter, enter. All right, so this is the point of intersection. This number rounds to -0.26, right, because the 4 afterwards, we keep that at a 6. And your y value is at 3.26. But let's think about it. What are we concerned with here, the x value or the y value? Well, let's look at our original equation. The original equation doesn't even contain any y's. It only contains x's, so the x values are what we're concerned with. So -0.26 would be the answer here. All right, so that is choice 1. Okay, so number 5 is similar to number 4. They just want to know, well, they give us 2 functions. They give us f of x and g of x, and they want to know when does f of x equal g of x. Okay, so here's f of x and here's g of x. If I want to know when they're equal, I'm going to do the same thing. I'm going to graphically, I'm going to plug f of x into y1, g of x into y2, and I'm going to find out their point of intersection. Okay, so here we go. I plugged f of x into y1, g of x into y2. And if you forget where the absolute value is, I mean, there's a couple places you can go to get it. I like to go right down here to math, and then over to NUM, and it's the first choice, see where it says ABS? Okay, so that's where I like to go. But anyway, once we have those into our y equals, I'm going to go to second, trace, and then intersect, which is choice 5. And let's see. All right, we have a few points of intersection, right? We have one here, and one there. So let's just start off with, I'm going to take my arrow key, let's start off with this one. I'm going to move it over here, right? And then I'm going to hit enter 3 times. 1, 2, 3. All right, so now we can see that, first of all, remember, we're only concerned with the x values, right? When I set these 2 functions equal to each other, doesn't the equation just contain x's? We're only concerned with the x values. You know, a key is when you see this, when one function equals another, that means x values only. All right, so we can actually automatically cross off choice 3 and 4, right? Because they wrote those as coordinates. Can't be that. All right, so if we take a look, it says here, I'm trying to go closer because my eyes are really bad. It says -3.8, and that one would round up to a 2 because of the 5, so -3.82. Oh, there it is, choice 1. Okay, so we didn't even have to bother finding these other points of intersection because the first one was right there. All right, so number 6 asks us to sketch these graphs. So we actually have to sketch them on the set of axes. It doesn't have to be perfect, it's just a sketch. And determine to the nearest 100th, so 2 decimal places, the solutions of when g of x equals h of x. Remember we said in the last question, when we see this written, when does one function equal another function, we're only concerned with the x values. All right, so here we go. So I went to y equals, I hope I plug this in right. I'm just double checking. Yep, everything looks good. And all right, so now I'm gonna go to graph, because I know I have to first sketch this graph. You could go right to second, trace, intersect if you want, but all right, so let's see. Now this is the only thing I'm concerned with. This is a cubic, x to the 3rd power, and I only see a quadratic, which leads me to believe I'm missing something. I should be seeing more on my graph. Now here's the deal. Since this is negative, remember, if it's cubic, it's going to have 3 directions, right? It's either going to go up, down, and back up, or it's going to go down, up, and back down. But if it's negative, remember, it always ends off going down. So what this leads me to believe is this is going to go down, up, and it's going to come back down, but it's off the screen. We're just not seeing it. So I need to make my x-axis a little bigger here, okay, so we could see what's going on. So let's see, I'm going to go up here to window, see where it says window, and my x maximum is currently at 10. let's make it 20. Let's see what happens. I'm gonna make that a 20. Okay, and now let me hit graph. And let's see if we see a little more going on. There we go. Okay, so you really got to think about that. Okay, you can't just be like, oh, look at that. That's what I see on my screen. There's only 2 points of intersection. Okay, this is a cubic. There's 3 directions. It's going down, up, and back down. So we had to make our screen bigger in order to find this. All right, so I'm going to hit pause for a minute and sketch this on my paper. Okay, so I did a total sketch. Nothing's great. Okay, here's the direction of my graph for g of x. Here's kind of the direction of my graph for h of x. I looked at my screen, I labeled, I put arrows, and what we could see is that there's 3 points of intersection, right? We have one here, and one here. And we're only really concerned with the x values, right? If I take this and set it equal to this, doesn't that only contain x's? So I'm gonna write over here x equals, next to this one x equals, and over here next to this one x equals. All right, so let me go on the calculator and let's find these points, these x values are the points of intersection. Okay, so sorry, this is kind of small, but I don't want to block my graph. I can make this a little, actually I could just zoom it back out when I need to. Okay, so the first thing I want to do is I want to go to second, trace, and choice 5, intersect. And all right, I want to move my cursor. I'm going to start with this first point of intersection. Now, I don't actually see my cursor, and the reason why, if you look down here, see where it says negative, see where it says it's at like 4 point something and 30.8? The reason I don't see it, because when x is 4 and y is 30, it's all the way up here somewhere, right? My graph only goes to 10. So I'm going to need to use my left arrow key to move it and keep going to the left until I get over here. Okay, so I'm going to hit my left arrow key, and I'm going to keep moving it, and look, there it is. Now I see it. And I'm going to move it as close to that point as possible. I can't look at this. I can't actually get on it. But as long as you're somewhere near it, you would hit enter, enter, enter. And we can see that our first, right, it's only the x values we're concerned with, is at negative 1.6. And they want it to the nearest hundredth. So we're going to have to include that 0, right, because the number after the 0 is a 1. So negative 1.60. Okay, let me make this smaller for a minute. Oops, it's a little crooked, but that's okay. And we're going to write over here negative 1.60. Okay, now, sorry, that was so sloppy, but all right, now let's find our next point of intersection. So we're going to go back to second, trace, intersect. All right, we're going to have to do this 3 times. And now I'm going to use the right arrow key to move this cursor to the next point of intersection, just anywhere near it. And then I'm going to hit enter, enter, enter until I see where it says intersection. Okay, there it is. And we can see this time it's at 1.79, right? That 9 after the 8 is going to round that up to a 9. So 1.79. All right, let me make that smaller out of the way. And let me write 1.79. All right, and then finally, we're going to find this last point over here. I'm going to just leave it small over here. So we're going to go back to second, trace, choice 5 again, intersect. And I'm going to use my right arrow key until I move my cursor. I don't know if you guys can actually see that. But the reason we can't is it's off the screen. See how this right here is at a height greater than 10? So I'm going to keep going to the right until I finally see my cursor. It's coming up. Did you see it? There it is. Okay, you see it right there? So now I'm going to hit enter, enter, enter. And we can see this x value is at 14.897. That's 7 is going to round this 89 up to a 90. So it's going to be 14.90. All right, so over here, I'm going to write 14.90. All right, so these are my 3 solutions to this. Now, if you prefer to write them in curly brackets, you can, but if you do, please write them in order from least to greatest. You don't have to do this. Actually, to be honest with you, the only reason I'm even doing this is because I was trying to balance my iPad while using the calculator and writing these at the same time, and it's going to get kind of messy, so I figure I'll just rewrite it. Number 7 wants us to solve this following system algebraically. Okay, so the first thing you want to do is you want to get either x or y by itself in one of the two equations. Now, we're not going to get x or y by itself in this equation because they're both trapped in a parenthesis, right, with a square on it. So that's going to be very difficult. So let's take a look at this equation over here. I'm just going to rewrite it. And to be honest, it doesn't matter whether you get the x or the y by itself in this equation. It's just as easy to work with either one. Okay, I'm going to get the y by itself. So in order to do that, I'm going to subtract 3x from both sides of the equation. So that'll leave me with 3y equals, now you could either write negative 3x plus 15, or you can just leave it as 15 minus 3x. That's up to you. It doesn't really matter. And then to get the y by itself, let's divide by 3. Okay, so we're going to, if we divide the left-hand side of the equation by 3, we have to divide the right-hand side of the equation by 3. All right, so that's going to leave me with y equals, and 15 divided by 3 is 5. Okay, we have to individually divide each term in the numerator by 3. And then I brought down this minus sign, and then 3x divided by 3 is just x, right? The 3's cancel off. So I'm left with y equals 5 minus x. Now, since y is equal to 5 minus x, right? Since we got the y by itself, I'm going to take what y is equal to, as 5 minus x, and I'm going to substitute it in for y into the other equation. All right, so now when we rewrite this equation, we're going to write it exactly like we see it, but in place of this y, I'm going to write 5 minus x. Okay, so just like this. So again, I rewrote this exactly like I saw it. The only difference is in place of y, since y is equal to 5 minus x, I replace this y with a 5 minus x. All right, so let's solve. Now, I know these are squared, which means we're going to have 2 of each, of these. But before we do that, in here, if you first combine your like terms, it's going to make your life easier for when you write this parenthesis out twice and distribute. So what I'm going to do is I'm going to combine the 5 minus 3, which gives me 2. So I'll rewrite this parenthesis as 2 minus x. Okay, and now, since both of these parentheses are squared, it means we have 2 of each of these. So let's write them out twice. All right, so now that we did that, let's just distribute everything out. All right, so x times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. Okay, and now I'm going to bring down this plus sign. Right, this is going to come right down. 2 times 2 is 4. 2 times negative x is negative 2x. Negative x times 2 is negative 2x. And negative x times negative x is positive x squared. And then I could bring down the equals 53. All right, so basically what I have to do at this point is I have to combine all my like terms, which I have a lot of them going on. And I also, since I have x squareds in my equation, I want to get this side of the equation set equal to 0. So I'm going to just subtract this 53. And I guess I'll line it up right here underneath these numerical terms. And that way, on the right-hand side of the equation, these cancel, and I'm left with 0. So now we have equals 0. I'm just going to put that right here, equals 0. All right, now on this side, let's see, I can combine x squared plus another x squared to give me 2x squared. All right, so now I can combine my 3x, negative 2x, and negative 2x. All right, so 3 plus 3 is 6, minus 2 is 4, minus 2 is 2. So positive 2x. So I'll write plus 2x. All right, and then I'm just going to combine my numbers. 9 plus 4 is 13, and 13 minus 53 is negative 40. All right, so here's our equation. Now, what I notice here, and I'm sure you guys do as well, is that see how all of these numbers are even? They're all divisible by 2. So what I'm going to do is I'm going to divide both sides of the equation by 2 just to make my life easier. So I'm going to divide the whole left-hand side of the equation by 2 as well as the right-hand side of the equation. All right, so basically 2 divided by 2 is 1, so we have 1x squared, which I'm just going to write as x squared. And then plus, again, 2 divided by 2 is 1, so we have plus 1x, or just plus x. And then minus 40 divided by 2 is 20. and then bring down the equals, and 0 divided by 2 is 0. All right, so from here, it's pretty straightforward. We're just going to factor, make a t-chart, and solve for the x values. All right, now, since there's a 1 in front of our first term, I set up 2 sets of parentheses, and I'm going to put an x in the first spot in each parenthesis. And I just want to come up with 2 numbers that add to positive 1 and multiply to negative 20. So it would be positive 5 and negative 4. And then I'm going to make my t-chart. So on the left side, I get x equals negative 5. And on the right side, I get x equals positive 4. Okay, now we're not going to stop here because if you recall, let me just kind of move the screen back up. If we look at our original equations, we have not just x values, but we're also solving for y. So we need to figure out what y values correspond with the x values we found. Now, see this equation right here, y equals 5 minus x? I think this equation is a little bit easier to solve for y in than our original 2 equations. So I'm going to use this one, y equals 5 minus x. Okay, so underneath these, I'm going to write y equals 5 minus x. All right, now what we're going to do is we're going to replace first this x value in for this x. So let's see, I'll have y equals 5 minus negative 5. Now we know if you have a minus negative, right, that's a plus. So we have 5 plus 5, so y is equal to 10. Okay, so basically when x equals negative 5, y equals positive 10. So this is going to be one of the points of intersection, negative 5, comma 10. All right, now let's come over here and we're going to replace this x with 4. All right, so we'll have y equals 5 minus 4. And since 5 minus 4 is 1, we know that when x equals 4, y equals 1. So 4, remember to always, when you write a coordinate, you're going to write the x first and then the y, x comma y. So when x is 4, y is 1. All right, so these are our 2 points of intersection, and it's always a really good idea to check. So like, for example, if you go back to your original equations, plug in negative 5 for x and 10 for y, and make sure that both equations check out. Also, plug in 4 for x and 1 for y, and make sure that it checks out in both equations. All right, so number 8 wants us to solve the system of equations algebraically. So even though we have to show our work algebraically, the first thing we're going to do is we're going to do this in our calculator and just, see what the actual answers are going to wind up being in the end. Okay, so the first thing we want to do is we want to come down over here to see where it says matrix. We want to hit second and then this button for matrix. If we want to go use our right arrow key to go over to edit, and you can hit enter. Now mine is already set up as a 3x4 matrix, which is what we want because we have 3 equations and we have really 3 rows and we have 4 columns. So if it says 1x1 or something else, just change this to a 3 and this to a 4, and then we can come right in here and start entering our numbers. Now remember, if we look here, we have a 2, a 3, a negative 4, and a negative 1. Okay, so I'm going to plug in 2, 3, negative 4, negative 1, and then we're going to do the same thing with the next row. So we have a 1, a negative 2, a 5, and a 3. So I'm going to hit 1, negative 2, 5, and then 3. And then our last row, we have a negative 4, a 1, another 1, and a 16. Okay, so once we have that all in there, we want to clear out of our screen. So see right here where it says quit? Okay, we're going to hit second mode. We're going to quit out of there. All right, so now we go back into matrix again. See where it says matrix? So we're going to hit second, and then the button that has the matrix above it. And when we go over to math, we're going to go, you could hit down, it's faster to go up until you see R, R, E, F. And then we go back to matrix for a third and final time. So second, little X inverse button, which has the matrix on top of it. And I'm going to hit enter because this is the one that we want to choose, right? The matrix that we just created. And when I hit enter again, you'll see that these are our answers, okay? Since x is the variable in the first column, y is the variable in the second column, and z is the variable in the third column, it goes x, y, z. So x equals -2, y equals 5, and z equals 3. Okay, and I just want to point out, the reason why we do this first, the reason why we come up with these first, is because that way, once you start solving and find your first variable, you know right away if you're on the right track. You don't want to get to the very end of the problem and do all this work and then check in your calculator and be like, oh, wait, look, I made a mistake. You want to know as soon as you make a mistake if there is a mistake. That way you can go back and fix it right away. All right, so let me get this off of here. That way we can get started. All right, so we're going to first label our equations, right? We usually label them A, B, and C. So this is A, this is B, and the next one is C. And then what we want to do is we want to decide which variables we want to cancel off. And we're going to cancel off those same variables in the first 2 steps. All right, I think I'm going to work with the x's. I'm going to try to eliminate the x's. So we're going to write out, okay, step 1, you want to say, because I know sometimes there's multiple steps, there's usually about 5, and you want it organized as to what you're doing first, what you're doing second, and so on. All right, so I'm going to take equation A and equation B. So let me start with that. So equation A and equation B. Now, if I line those up, the x's are not going to cancel, right? But if I multiply equation B by -2, I'll have a -2x here, which will cancel off with a +2x. So I'm going to put a -2 in front of the B. Now, keep in mind, this is just one way to do it. I mean, there are so many different ways to go about solving this, so your work may not match up with my work at all. Okay, so equation A I'm leaving alone, so I'm going to rewrite that. All right, and then this next part is up to you. Some of you guys might want to put, a -2 in front of this equation and show that you're distributing. I personally don't like to do that. I feel like more on the paper kind of sometimes creates a little bit of chaos, but if you like to do that, go ahead and do it. Okay, I like to just kind of distribute to the problem up at the top. So negative, but remember to distribute to everything, just like you would if this was in parentheses with the -2 in front. All right, so -2 times x is -2x. -2 times -2 is +4, so we have +4y. Okay, -2 times +5 is -10, so we have -10z. And then finally, -2 times 3 is -6. All right, so now we're going to just add these 2 equations together. So the x's cancel like we wanted them to, and then we get 7y minus 14z equals -7. And since we've created a new equation that we're going to need to use, I'm going to call that a new variable, so we'll call that d. All right, step 2. Now in step 2, you want to eliminate the same variable that you eliminated in step 1. So here we eliminated the x's. Now since we already used a and b, we have to pick a different pair of equations to use. So we could either use a and c, or we could use b and c. All right, I'm going to use a and c. Now if you look here, c says -4x. So if we multiply this by by +2, wouldn't that be a +4x, which cancels off with our -4x? All right, so first of all, I'm using equation A and C, but I'm going to be multiplying equation A by +2. So I'm going to put a +2 right there. All right, so let's distribute. 2 times 2 is 4, so we have 4x. 2 times 3 is 6, so we have +6y. 2 times -4 is -8, so that gives us -8z. And then 2 times -1 is -2, so it equals -2. Now equation C we're just leaving alone, so I'm just going to take that and copy it right from the top of the page. And now we can just add them together. So again, the x's cancel off, which is what we want, right? You want the same variable to cancel off in step 1 and in step 2. All right, so then we have 7y minus 7z equals 14. Okay, now that we created a new equation that we're going to be using, I'm going to call that equation E. Okay, so what we've done here is we've created 2 equations in 2 variables, right? Y and z. And now we can use those to eliminate one of the variables. Okay, Doesn't matter which one you eliminate. Here I have a positive 7y, and here I also have a positive 7y. So if I multiply one of these equations by a negative 1, the y's will cancel off. All right, so step 3, I'm going to use equations D and E, and I need to multiply one of them by a negative 1. Okay, it doesn't matter which one. I'm going to choose equation D just because this is negative and a negative times negative will make that positive. Not that it matters at all, but I'm going to multiply equation D by negative 1. Okay, so let's distribute them. Negative 1 times positive 7 is negative 7, so we have negative 7y. Negative 1 times negative 14z would be positive 14z. And then bring down the equals, and negative 1 times negative 7 is positive 7. Okay, and then equation E I'm just leaving alone. And now when we add these together, what's going to happen is the y's cancel off. So we have 7z equals 21, and that allows us to solve for z. So when we divide both sides by 7, we get z equals 3. Okay, so now this is where you want to go back and look at your answers at the top of the page and say, does this match up with what our calculator gave us? So let me scroll back up here. And yes, look, you could see z equals 3. So we know we're on the right track. All right, so that's why it's important to do these first. You don't want to go through the whole problem and be like, oh, wait, I made a mistake in the first step. You want to find that mistake as soon as possible. And hopefully you don't even make any mistakes, okay? All right, so now we're on step 4. Now in step 4, what we're going to do is we're going to go back to either equation D or E. Because think about it. Now that we know that z is 3, if we plug in a 3 for z, then we could solve for y. Okay, so you can use either one of these two equations. It doesn't matter. I'm going to use equation E. And I'm going to replace the z with a 3 because we now know that z equals 3. Okay, so again, I just move this up. I just took this equation and I replaced the z with a 3. And now we're just going to solve. So 7y minus 21 equals 14. All right, so in order to solve for y, we're going to add 21 to both sides of the equation. So that'll leave us with 7y equals 35. And then when we divide both sides of the equation by 7, it gives us y equals 5. All right, so let me look up at the top here and see. Yep, look, y equals 5. So again, we know we're almost there, okay? We're doing everything right so far. All right, so now finally, step 5. We know 2 of the 3 variables. So let's see, we know the y and we know the z. So the only thing we don't know is the x. So basically, you can go back to any one of these original equations. I'm going to use equation B because x is by itself. And we're just going to plug in 5 for y and 3 for z, and we'll use that to solve for x. Okay, so let's see, I'm going to write down equation B. So we have x minus 2 times, well, y is 5, so I'm going to replace that with a 5. And then plus 5 times, well, we know z is 3, and then equals 3. Okay, so again, I just used this equation, and I replaced the y with a 5 and a z with a 3. All right, so let's solve this. So I have x minus 2 times 5 is 10, and then plus 5 times 3 is 15, equals 3. So x, if you combine negative 10 and positive 15, it gives us positive 5, and then equals 3. And then when you subtract 5 from both sides of the equation, you end up with x equals negative 2. And let me go back up to the top, and hopefully that matches up as well. And there we have it. It does. All right, and finally the last question. So if we look at this system, first thing I want you to notice is that in the second equation here, okay, the c is on the right-hand side of the equation. So I'm going to take that and subtract it over to the left-hand side of the equation. That way we have all our a's, b's, and c's in line, all on the left-hand side of the equation. Okay, so when I do, this is what it looks like. So I have the negative 2a. I have the positive 6b, and then this c, when I move it to the other side of the equation, its sign changes, so this becomes minus c, and then I'm just left with this 3 on the right-hand side. All right, so these are our 3 equations. I just rewrote them, and I'm going to use my calculator to create a matrix and just find out what the solutions are before we get started doing it by hand. All right, so what we're going to do is we're going to go to second, and then we're looking for the button that says matrix on top, and we're going to go over to edit and hit enter. Now, if this already says 3 by 4, you're all set because we have 3 rows and 4 columns. 1 for the A's, 1 for the B's, 1 for the C's, although I'm blocking it here, and 1 for the numbers. You know what, let me move this over so we could see our equations. Okay, so now, so this already says 3 by 4, so I'm just going to hit enter and go past that. And if we look at our first row, okay, there's a 1 in front of this A, a -3 in front of the B, a 4 in front of the C, and then there's a number all by itself at the end. So when I plug in the numbers for my first row, it's going to go 1, -3, 4, 23. Okay, so I'm going to plug in a 1, a -3, a 4, and a 23. All right, I'm going to do that for the next row. So the next row, you can see it says -2, 6, -1, 3. So I'm going to hit -2, 6, -1, and 3. Okay, and then the last row, we have 5, -12, 7, 26. So 5, -12, 7, and 26. All right, and then once you have them in there, we want to clear out of here. So see where it says quit right there above mode? We're going to hit second mode. And we're going to go back to matrix, so second, and then the button that has the matrix on it. And if you go over to math and scroll up rather than down, because it's faster, you're going to go until you see RREF. And we can hit enter on that. And then we're going to go to matrix for the third and final time, so second. And then matrix is right here. And this time we're going to, we're going to actually just hit enter on this first matrix here. This is the matrix that we want to use. And when you hit enter again, you'll see that these numbers are -3 represents A. Now this is a decimal. Some of you may recognize this as 2/3. If you don't, you'll have to, later on in the problem, when you start solving, you'll have to see what type of fraction you get and see if that fraction is equivalent to 0.6 repeating. And then finally, the C is 7. Okay, so let me just move this over. So we have, in our answer key box, we have A equals -3. Okay, and I'm getting that right from here. I do recognize this as 2/3, right? 0.3 repeating is 1/3, 0.6 repeating is 2/3. So I'm going to write this right now as B equals 2/3. Remember, if you don't know that by hand, just leave this blank for now. We'll take care of that later. And then C is equal to +7. All right, so let's get started solving this by hand. Okay, so in the first 2 steps, you want to try to eliminate the same variable. So you have to look up here and decide which variable you want to eliminate. All right, I'm going to actually eliminate, I think, the B's. So in my first step, I'm going to use equation A and equation B. Okay, now if you notice, the B's aren't going to cancel off, but if I multiply equation A by 2, isn't -3 times 2 -6, and won't a -6b cancel off with a +6b? Okay, so what I'm going to do is I'm going to do 2 times equation A. And then I'm going to also just leave equation B as is. All right, so like I said in the last example, if you want to put a 2 and then in parentheses write equation A and show that you're distributing and rewrite it, you can do that. I personally don't like to do that because I feel like it becomes a lot of clutter on the paper. So that's a personal preference, whatever you like. So I like to just distribute up to my equations at the top of the page. So 2 times A is 2A. 2 times -3b is -6b. 2 times 4c is 8c. And then 2 times 23 is 46. And I said I'm just going to leave equation, I don't know why my 6's are coming out so funky today. I said I'm going to leave equation B alone. Actually, look what happens here. So I was trying to eliminate the B's, but look at this. Not only do the B's cancel off, but the A's cancel off too. So I'm going to cancel off the A's and the B's. All right, so that leaves me with 8c minus 1c is 7c, and 46 plus 3 is 49. So I'm able to solve for C in this first step. Okay, so it gives me C equals 7. And if I look up here, look at that. C does equal 7, so we're on the right track. Okay, Let me just go like this. Okay, so now I have to decide, I guess I have to go back to square one. So in step 2, I'm going to do that right over here. Step 2. All right, well, I have to decide. I can go back to the original problems and eliminate any variable I want at this point. So let's see. I think I'm going to line up equations A and C, and I'm going to eliminate the A's, okay? So here, if I multiplied, this is a 5A. If I multiplied equation A by -5, then I'd have a -5A to cancel off with a positive 5A. Okay, so I'm going to do -5 times A. And remember, everyone could do these a different way. So, the way I'm doing it, you may have totally different work on your paper. But as long as we wind up with the same answers in the end, that's what counts. All right, so -5 times A is -5A. And again, remember, if you prefer, I should have said this before I started here, if you prefer to write -5 and then put equation A in parentheses and distribute, okay, you can do that. If that helps you to keep, your work organized, then do that. That's up to you. All right, anyway, so back to this. -5 times -3b is positive 15b. -5 times 4c would be -20c. And then -5 times 23 would be -115. All right, and I'm just leaving equation C as is. All right, so now when we combine these, the A's cancel. Since 15 minus 12 is 3, we get 3b. And then since -20 plus 7 is -13, we get -13c. And then finally, when I combine -115 and positive 26, I get -89. Now, I created a new equation here that I'm probably going to be using, so I'm going to call that equation D. Now, normally what we do is we try to line up another pair of equations and eliminate the same variable, but we don't really have to, because look at this. If we have this equation in terms of B and C, don't we already know the C is 7? So can't I just substitute this with a 7? And then I can solve for the variable of B. So step 3, all right, I'm going to just use equation D. And I can write 3b minus 13, and I'm going to replace this C with a 7, so minus 13 times 7 equals -89. All right, so then we have 3b minus 13 times 7 is 91 equals -89. And then we're going to add 91 to both sides of the equation. So we get 3b equals positive 2, and then divide by 3. And we do wind up with b equals 2/3, which I can kind of see at the top of the screen right here, right? Look at that. b equals 2/3. Now, in the calculator before, if you recall when we, came up with our answers before ever doing this by hand, do you remember that it said b equals 0.66666 repeating? Well, if you're not sure if this is equivalent to 0.666 repeating, just plug 2 divided by 3 in the calculator, and you'll see 2 divided by 3, 2/3 does equal 0.6 repeating. So if you had originally written this as 0.666 or, 0.6 bar, please erase that. Okay, we want to put an exact answer, which is 2/3. So let's make this b up here at 2/3. Actually, we're going to finish this in 4 steps, because if we already know our b and our c, we can go back to any one of these original equations and plug in b and plug in c to help us solve for a. All right, I'm going to use equation A. So this equation, let me just make myself some room. So I'm going to move this down. All right, so step 4. All right, so equation A had said A minus 3b plus 4c equals 23. All right, well, so A minus 3 times, we know that B is equal to 2/3, right? We just found that out, so let's plug that in. And plus 4 times, well, we know that C is equal to 7, so let's replace that with a 7. And then equals 23. All right, so A minus. Well, 3 times 2/3 is just 2. Because think about it. If you put this 3 over 1, wouldn't this 3 on top cancel with the 3 on bottom, leaving you with just 2 over 1, which is 2. And then plus 4 times 7 is 28. Now, if we combine our like terms, -2 plus 28 would be positive 26. And then finally, to finish up, we would just subtract 26 from both sides of the equation, which leaves us with A equals -3. And let me just look back up at the top and make sure that's what we got to make sure it checks out. Oop. Yeah, and there we go. Look, A equals -3. So these are our answers.